Good afternoon, ladies and gentlemen. Today we're going to work on box plots, otherwise known as box and whisker plots. So our I can statement is I can organize data into a box plot. Okay, so there are 5 steps. Step 1 is you order the numbers from least to greatest. So let's go ahead and take a look at our data set. This says these are the ages of children taking dance classes. So we're going to put them in order from least to greatest according to step 1. All right, so let's get started. Looks like our least number is 7, then 8, then 9, 10, but there are 3 of them, so 10 and 10. All right, now we're moving on to 12, 14, 14, 16. All right. So step 2 says draw a number line that covers the range of the data. Well, we've already done that down here. Here's our number line. And since our range starts at 7 and goes to 16, this one goes from 6 to 18, so that works perfectly. All right, step 3. Find the median, the extremes, outliers, and the first and third quartiles. Okay, so we take our number, and remember that the median is the middle number, so we're going to start here at the ends and work our way to the middle. And since 10 and 10 are 2 numbers and they're both in the middle, the median is 10. Okay, and then we're going to find the first quartile, which is the median of the lower half. So we start here at 10 and 7, work our way to the middle. Oh, look, it's 9. So the first quartile is 9. And then we're going to move to the third quartile, which is the median of the back half. So from 10 to 16, work our way to the middle. Ooh, 14 is the third quartile. All right, and then we find our inner quartile range. So the inner quartile range is the difference between the third and the first quartile. So 14 minus 9. Which is 5. And then we multiply that by 1.5. Put in the decimal. Okay. Now, since our product, this is our product, and I did forget to write that down, we're going to do 7.5 plus the third, which is 14. And we're going to do the first 9 minus 7.5. All right, so let's do the addition. $21.5. Remember that when you're subtracting and you have a decimal, you line it up and you put zeros in for the place values that are missing. 10 minus 5 is 5. Okay, so here's the deal. It says, are there any outliers? Well, our outliers need to be outside of 1.5 and 21.5. So when I look up here, 7 is not less than 1.5. That's our least number. And 16 is not greater than 21.5. So therefore, there are no outliers. And so we don't need to list them. Upper extreme is the greatest number. Okay, so upper extreme would be 16. Lower extreme is the least number. So lower extreme is 7. So LE, UE. All right, so you see all these points that we've measured right here? All 5 of these points need to be listed on the number line. So this is step 4. All right, so we got 7, put a dot, 9, put a dot, 10, okay, 14, and 16. From here, draw a box so it includes the first quartile, median, and third quartile. So that would be 9, 10, and 14. So 9, 10, and 14 is our box. Okay. Draw a vertical line through the median. So it separates that box into two boxes. And draw a whisker, that's why they called it in the beginning a box and whisker plot, to each of the upper and lower extremes. And now you've created a box plot. Okay, so one thing that I want to talk to you guys about in a box plot is a box plot is separated into 4 equal parts. Those 4 equal parts are worth 25% each. So if I was to ask you, I don't know, what percent of the box plot is 10 or greater, that would be these. So 25 plus 25 would be 50% of the box plot. How about 10 or less? 25 plus 25 is 50% of the box plot. You could say 14 or more, 25%. 14 or less, 25, 50, 75 total. Okay, so when you're looking at a box plot, it is separated into 4 equal sections, and those 4 equal sections represent 25% each. Okay guys, I'll talk to you later. We are going to move on to the next one.